Nice, Amy. Thank you. Thank you. Good evening. It's amazing to be here in the packed hall. Huge thanks to you all making here, and also, to the organizers for making this a great show. Complexity is something I hear a lot these days. When I say these days, last few years or 5 years or something like that, many engineers cry about complexity. Everything is so complex. If I think of back in those days, 90s, we never complained about complexity. Even if we did, no one bothered. That's the fact, right? I'm standing here, owner of one of the most complex systems in the world. I agree with Bill Gates. Some people say, oh no, it's not the body, it's the brain. I'm like, isn't the brain part of your body, or you keep it outside? No. The fact is, we didn't have a choice, right? We born with a complex system. But then the interesting bit happens. Paul, in his talk title, mentioned that crawl, walk, run. So we learned that. We know we need to sit before we stand, stand before we walk, walk before we run. Now we know how to handle this complex system. And we accept the fact that, this is how we are. And, people say that, oh, internally you have all these things, and we believe them. We understand that things are not that simple. So we learn how to manage our system, right? That's how it is. Now, Tesla's law talks about complexity. And he says, almost every application has some element of complexity, and you can't do anything about it. All you can do is, you can move things around, push it here, there, etc. But that's how it is. So, based on that, I have a brief agenda today. So, we'll look at, making you all accepting complexity. Then we will see how to understand some of the complex elements associated with engineering and life. And then we will look at few ways how we can better manage complexity in engineering, especially when it comes to cloud and serverless. The fact is, I must confess you something. All amazing speakers before me, they already spilled all the beans of what I would talk about. So, so let's see. My name is Sheen Brisals, and I'm an AWS Serverless hero. I'm an independent consultant now. I co-authored this book. It came out last year. I think we have a few copies to give away after, during the network hour. And I'm currently writing this book. It's, its early release version is out there. And I'm on it at the moment. And speaking of books, O'Reilly has kindly offered us, code for month-long free access. So it's not just O'Reilly books you can read. O'Reilly also provides books from other major publishers. So if you want to make use of that, please scan it. I think Michelle will show that later on as well. Right. So how do we acknowledge complexity? Now, the fact is, we need to first create the awareness so that we can accept the fact that things are complex. Complexity is there everywhere, right? It's in our life and environment, and wherever you look, complexity is there. Say, for example, this beautiful looking picture. You have a landmark rock on that side and beautiful sandy beach on the other side. Which one is complex? You will know if you get permission to break the rock, right? The tools you need and how complex or accumulated its density is. On the other side, any child can scoop sand and build sand castles. But there are too many sand particles, right? And the sand gets reshaped, every wave hits the shore, right? So complexity is there in every part. And sometimes complexity is not bad, because especially when it comes to dealing with our safety, business criticality and things like that, we accept that. For example, the largest passenger airliner ever built, okay, to carry all these things, up in the air and fly non-stop for hours, it has to be complex. We can't say that, you know what, you have far too many engines. Why don't we get rid of two? Make it simple, right? I'm sure none of us will ever onboard the aircraft. So there we need complexity because there is a necessity for it. And in business, exactly that's what's happening. What we call this is the essential complexity. I know you heard the term early on from Dave as well. Now, if you think of enterprises, they are a complex beast, right? Because of all these reasons. There are so many people, different technologies, all over the world, policies, so on and so forth. So you can expect operating an enterprise has to be complex, not just technology. Even the business side of things has complexity, in it. And say a takeaway app, simple app. You just, click a couple of things or tap, you get the feeds are delivered. But behind the scenes, it has so many modules beyond what I show here. So that is just to operate a takeaway app or something simple, right? So behind, you see all these operations happening to make the things happen. So complexity is, is everywhere, and, we can't often always ignore. We need to accept that. So with that one, let's look at, what complexity is basically. So according to Wikipedia, the focus is more on the integration or the communication between, the components. And early on, Dave showed the complexity. So for me, the sign of complexity is something like this. It's not those shapes, it's not those rectangles and squares and things, those lines connecting them. That's what, they cause the complexity. And especially when you work in teams, I say something like the expression of complexity. I'm sure you must have seen the expression of complexity in your teams as well. So this is roughly how it looks, right? So when you know someone made the last one, you know that's really complicated, right? So the reason because of this stuff. So many of you, I think you must be familiar with this typical nodes and lines pattern, right? Again here, not the number of nodes or the dots, is the connections between them. That's what make things complicated. So here is a simple serverless architecture. You can take it to any cloud provider. Again, those services don't make that complicated, but the lines crisscrossing all over the place. That's exactly what Vlad in his book is talking about when he deals, when he talks about complexity. It's the cognitive load comes because of dealing with these so many connections, but thinking of, where does this come from, and who is consuming, how many are consuming API, and etc., etc. So that is the cognitive load that adds on to engineers and bring the whole complexity complaints to our teams. Now, how do we measure complexity? So this is a famous framework. Who is Welsh here? Anyone Welsh? Yeah, please. Please pronounce that to everyone. Canafin. Yeah, right. Thank you. I won't say that again. So this framework is used for decision making. So it goes like clockwise from chaotic all the way to clear. When it's clear, everything is clear. What they call as known knowns. We know everything. Everything is simple. When it comes to complicated, it's the known unknowns. So we know what are the unknowns out there, so it becomes easier to work out. When it's complex, it's completely, unknowns of unknowns. We have no clue whatsoever what's out there. So the way to, improve that is experimentation. Try out few things and then get going. So this is fine for decision making, but on engineering side, on our side, I picture in a different way. So I have two sides of complexity. So on one side, we have the accumulated complexity. Think of the rock I showed earlier. It's kind of accumulated with all the particles, densely. On the other side, you have the distributed complexity. And then you have the hidden complexity can be hidden behind, or it is quite visible but still complex. I'll give you an example after this. And then disorganized and organized. These things are not new. If you go back to the 70s, our computer scientists, they mentioned complexity even those days. So structured design back in 70s talks about local and global complexity. Of course, we didn't have cloud or distributed systems like we have, but they talked about the program complexity within a program or between the programs. Typically, you think of local variables or global variables or shared memories. So those are the ideas they even talked about back in those days. Now, to give an example, so let's say you have a monolith. So immediately you think that, it's kind of fully, accumulated, hidden with complexities. On the other hand, we have our beautiful distributed system that all over the place, and it has all the domain boundaries and communication lines and so on and so forth. But for many, this is also complex because of, the too many of them. And they say, microservices. But what we do is we make it a microlith, stuff everything together into a single deployment, then suffer the consequences. The same with Lambda Lith or even Azure and other providers, the function Lith. People argue that there's a long argument whether you have a single Lambda function that handles 10 different API routes or a single purpose simple Lambda function. So that is there. So it's always there that we can't kind of ignore or avoid. So given that sort of context, how can we manage complexity? So this word simplexity became popular from AWS reInvent last year, where Werner Vogels mentioned the term. And he made an important point in that narration. Now, the many services we call simple storage service, simple notification, simple email, they all provided or kind of offered to us as simple services, but they are complex services behind the scene. But the difference is they all built with simplicity principles. So that allows teams to develop further, extend, add new features and things like that. So here is the cockpit of A380, for example. Okay, so there are so many buttons, knobs, dials, all sorts of things. But if you think about the simplicity principle here, each knob or button probably is going to do one thing because they all kind of arranged neatly to tackle the complexity behind operating such a huge aircraft, right? So I'll go through 4 or 5 ways how we can kind of deal with complexity. The first one is decompose complexity. Now that's easier said than done because according to this author and the book, decomposing is our most problem that we face because engineers can't get around their head how to decompose a problem or something complex. Now, there is a clue in the continuous architecture book, and it's there on number 4. Leverage the power of small. This is going back to the simplicity principle again. So this is exactly what teams out there are doing to deal with complexity. Teams like cloud providers, and when they offer these sort of beast of services like DynamoDB or S3, behind the scenes they apply these principles. Now you heard plenty of domain-driven design today, so I won't talk too much. So basically, break down, decompose the problem from the top, complexity from the top, from the business, domains and subdomains, and you have the bounded contexts. And once you have the bounded context boundaries, it becomes easier to bring in ownership. That is your autonomous teams owning a part of a domain, right? So when you get to this level, it becomes easier to manage complexity because you have one focus to work on. Teams know exactly what to do, and and then they can kind of add on new things. Now, what this gives us is with the domain boundaries, we get to the distributed system. So you can easily distribute across your organization or beyond because they all have the boundaries. And with the team boundaries, you get the ownership, the autonomy. Teams know exactly what they're working on and how they should be building. And they have their own code base. They're not sharing with a bunch of teams. They operate with their own AWS or any cloud account. And then with the responsibility boundaries, that's where all the API contracts and event schemas and identifying your synchronous versus asynchronous nature of operation, these things come in, right? So the next one is prevent communication complication. I think I introduced a new word. English is funny, right? If we have a simplification, why can't we have a complication? There we go. And this is important. If you are building event-driven architecture, apply your brain. Otherwise, you're opening the floodgates to become a distributed monolith. I will give you an example now. Amazon Event Bridge is a wonderful service. I love it. I've been kind of blogging since its release in 2019. I'm a great advocate of Event Bridge. Now, they introduced the cross-account event bus to event bridge communication a while ago. That really helped teams to kind of streamline the event-driven communication between different cloud accounts, okay? And a month ago, the internet was on fire because of this. A new feature was released where from one AWS account, Event Bridge, you can send events to another resource, a Lambda function, queue, SNS on a different AWS account. And it was kind of topping the chart on InfoQ. It pushed one of my articles down because of, it was climbing the popularity. I sometimes say this at conference talks. Some technologies are complex by nature. And then what we do is we create complexity using simple technologies. I once mentioned a technology for the top one, and someone confronted me. Sheen, you mentioned that name because you are a serverless hero, right? So I decided I'm not going to say it. I will, refer to Wikipedia. Now, anyway. Let's bring back the event bridge communication. If you don't apply your brain with the newfound, freedom of doing communication, what you will end up with is this. That is exactly what a distributed monolith is, because you have no control which accounts your account is talking to or linked to or connected to, coupled to, depending on. And that is exactly the situation we must avoid when we build event-driven architectures. This is kind of what we call the accidental complexity, the other side of the essential complexity. Now, so don't do these things, okay? When you, in the name of simplification, don't bring in accidental complexity. And then the cross-account communication, as I mentioned, don't make it just into a chaos. Don't make event-driven as an event intruder pattern. This is something I came up with recently. That's exactly what will happen if you're not careful in communicating with a bunch of accounts around. And then essential complexity is exactly what I mentioned. So you may be asking, okay, Sheen, that's fine. We all laughed. Tell me how to do it properly, right? So this is an approach you can think of. But of course, it's not that easy. promote or elevate a dedicated account that runs one or more event buses as your domain bus or your enterprise event bus. Now it is possible to connect to the different resources. That means you can build governance and control on this account so that you can manage which resources are being connected or targeted to. So that allows you to be control or manage complexity. You can do a bunch of things. You can wrap microservices to do all sorts of security checkings or encrypting, decrypting, hashing, etc., etc. So this is one way of dealing with complexity, especially in when architectures. The next one is architecture evolution. Promote it. Now, so this is from a great architect. So he talks about the building architecture, but we have a difference. Like if you think of architectures around here, they don't change much, right? They hardly change, whereas software architecture constantly changes, right? So that's why we need to bring in, or we need to employ the necessary principles or guardrails to keep it simple. So modularity is one thing. I mean, Vlad in his book talks about these two things. So when you think of modular systems, because you are like module or a component or service, that means you are not kind of creating accidental complexity by spilling all the complexities outside. And also, because of the modularity, it is kind of encapsulating much of some of the complexities. So that means you manage it, within a module or within your microservice or within your kind of bounded context. And modularity, of course, gives us the extendability option. When you are modular, you can extend it. And also observe. We heard the talk about the observability earlier on. So if we can't observe a system, there is no way you can manage it in terms of complexity or even for extending. So that's important. And also, when you think of modularity, you can think of the primitives. So those days, the program primitives people think. These days, people talk about the cloud services as primitives, because you can now compose or construct microservices using those primitives. So that's why I've been saying that in serverless, you build microservices by composing other services, cloud services or managed services. You're not like programming everything. You're like kind of knitting together with infrastructure as code to bring your microservice there. And recently I came across this term like composition as code. I thought, okay, so that is like new kind of as a service term coming up. So that's modularity. So the next thing is event. Again, you heard plenty of this. What I want to talk about events is, don't just dump anything onto an event bus or a stream. Think, come up with a structure or a schema that you can share across your teams or the organization. So that means there is a unified representation of your events, right? So this is important. And then think of events, the versioning and identity. How many of you, when you consume an event from a producer, how many of you check for the version before accepting or processing it? Many teams don't do that. Then what happens? When the upstream or the producer updates the version, they do a version 1.2, then they complain, oh, everything is broken, that team changed everything. Yeah, they did, but they also had a version number. You didn't listen to that. So make sure that you use the version number. Then identity. And there was a mention early on in one of the talks. This is how you know exactly where this event originated and coming from. All the from the domain and the team or the service. So these are the essential aspects you need to bring in when you deal with events. Then the data privacy aspect. Don't dump everything as data into the event. These days, GDPR, PII, sensitive data, There are guidelines to do. If you need to encrypt, you have to. If you need to hash, you have to. The best thing is don't put everything there. Then use a different pattern like climb check and things like that to provide the data whoever needs the data. So expose absolute minimum. And then finally, this is just me. You probably don't need to follow it. Try to categorize the events. So domain events are like a gold events, right? So they go across your domain. Whereas within your bounded context, you may have local events. They just, kind of carry something, operational events. They carry, some alarm measures and things like that. Those events of no interest to anyone outside of your bounded context or domain. So think of those, the ways you differentiate to bring the, calmness to your situation, and then protect with patterns. So in serverless, we're blessed with plenty of patterns because we can kind of borrow all the good patterns from years and then come up with our own pattern. So I'm going to talk about just two patterns. Again, one I think Lee spoke about early on. So it's slightly different version of it. So the gatekeeper pattern is basically a way to block the event data going out and in, not block in the sense, manage, right? So as a gatekeeper. So how does this work is, say you have a bounded context, say it's payments. So this is again where I differ from some of the other, representations. But for me, in serverless, in a bounded context, you can have number of microservices. It's not just one microservice. Anyway, so you have a local bus here where the events are getting streamed to. Then there are a bunch of external applications, third parties or other domain services and things like that. So they require different data or different interactions between them. So it's fine if you don't have many events. But when you have so many events, they are kind of flowing across this bus. It could be domain events, it could be your local events, and so on and so forth. And also, some of those, downstream consumers may need event in a different format, or you may need to do a cross-account setup and things like that. So this is where I propose that you have a dedicated event bus that acts as a kind of a gatekeeper. So that means the external communications from your bounded context is managed by that bus. So the other bus has no clue whatsoever about whether you are async API or cloud events or whatever. So that's all it's others' responsibility. So you can even wrap that as a microservice. You can do the governance or management of those aspects as well. So that's the pattern I propose, and also in this book that is explained in detail as well. So the next one is related to the previous one. It's more generic, the anti-corruption layer. An important pattern many teams overlook. They just don't care these days, especially when it comes to the sort of easier implementation of serverless. They just don't get it. Because if something came up 20 years ago in a DDD book and no one read it, but it doesn't need to be that way. So here is certain patterns from the the domain-driven design, and the middle part is basically the consumer and the provider or the supplier. So that's where the anti-corruption layer comes in, and also its opposite is the open host service. So how does it work? So when you have a bounded context again, so think if it's an order, it has a bunch of microservices, and it has to deal with external parties to communicate. So there is a payment subsystem. So it makes a synchronous call. There's no worries because they provide the API for the orders to hit, and then the payment sends an asynchronous communication event back in. That data comes in dictated by the payments structure, not orders one. So that's where you need to bring in an anti-corruption layer to protect the model of the order bounded context. So that means you're not polluting your data model with somebody else's data model. So that's where you can, kind of build a little microservice or do a, anti-corruption layer so that you do the translation or transformation before you accept the data internally. The same way you can do, communication between the other parties as well. So when you have a sort of an event-driven communication via the event broker, you can do the same thing before you accept the data model into it. And again, when you push something out, like the previous pattern, the gatekeeper, you can now think of the other pattern. How do you kind of prepare the data before you send out for somebody else to consume? And if you want to know more, I wrote this blog, I think maybe a year ago or something like that. So it has more details on, how we can learn and to put that into practice in serverless. So I insist this pattern a lot, especially in the serverless community, because I know that typical, the microservices, the community, they adopt because they closely follow the DDD patterns. Whereas when it comes to serverless, I see these, teams often miss these sort of, crucial implementation aspects. And finally, refactor complexity. Now, Werner said at the reInvent that complexity will creep in all the time. So if you just stand there and watch, then it will kind of accumulate as tech debt, right? So that's why we need to constantly refactor. Refactoring is not a new thing. Probably most of you know. I mean, UML, if Grady Booth, the UML guy. So he mentioned that a while ago that the refactoring should be part of the culture. Now, if you are completely new to refactoring concept, these are the old books back in those days, and the difference is, those days these books mostly focused on object-oriented programming and program refactoring, because that's what engineers were doing, right? We're just programming those days. But nowadays, though, with serverless and cloud, we are not just refactoring the function code. We are refactoring the entire service. We are like rewiring new services and new features as they come along. So that aspect should be there, and it should be a continuous process, especially in modern cloud and serverless teams. So what are the things we can refactor? We can do program refactor, infrastructure, architecture, so on and so forth. The point is that refactor complexity before it hits. Again, I wrote, I think it's probably a few years old now, but still valid to understand how you can put that into practice. And also I talk about how you can take this refactoring message to your stakeholders, because often when you say refactoring, they think that, refactoring is going to be 5 months, 6 months, typical legacy refactoring mindset. But there are ways you can kind of, make stakeholders understand what this refactoring will bring to your team. Right, so to close, those points that I mentioned, the first thing is that accepting, and then you bring in the essential complexity but block all the accidental complexity, so that's harmful to your your system, and then decompose. Okay, so I know many organization teams and follow the DDD principles. Do that. If it brings kind of benefits to your organization, be a team, don't hesitate. Go for it. It may take a while to get up there, but make a start and build things for kind of evolvability and modular systems. And finally, prevent, protect. That's the message for the anti-corruption layer, and of course, refactor. I leave you with this this phrase, because these days, however we complain, the distributed systems is a need for us, a need for the society. That means it will bring some element of complexity. All we can do is use those simplicity principles to manage the complexity, so that we are always on top of dealing with complexity. That means we can happily embrace complexity. Thank you so much, and enjoy the bar afterwards. Thank you.